Hello, I'm Dr. Aliana Moran. Today we're going to discuss two different algorithms that are somewhat comparable in natural language processing. These are Tf-Idf, standing for term frequency times inverse document frequency, and Word2Vec and Doc2Vec, variants on the same theme that are more recent algorithms and typically useful for larger corpora. Now, the reason that we're having this little discussion, which is sort of a bonus add-on to what I plan to do in terms of going through the mathematics of the different methods, is that students will typically run both algorithms on the same corpus, which is the right thing to do, and they'll report the results, and they'll say, this worked better for me than the other, which is the right thing to do. They won't always have a sense of intuition, like they can't always articulate, this is why a certain algorithm performed better for me. And so in this very short little vid, we're going to drill down just a little bit into the whys and wherefores. You, running an algorithm on a corpus of your choosing, might find one algorithm more suited to your needs than another. Let's jump to the slide deck, shall we? This video is part of a series on natural language processing. In this vid, we address text vectorization. Specifically, we're going to compare Tf-Idf versus the Word2Vec, Doc2Vec algorithms. In other vids, we've already taken a look at the overview, and upcoming, yet to be produced, we're going to take a look at clustering, topic mapping, and other things. Just for quick context, we're looking at doing text vectorization after we've already extracted the terms from a set of documents. Our goal now is to produce a reference term vector that characterizes the important terms within that corpus or collection of documents. As I mentioned, there's two general classes of algorithms that we're looking at. The first of these, term frequency times inverse document frequency, is a very well-known algorithm, and it's pre-2000. The second of these, and we're really just going to focus on the Doc2Vec, we'll leave the Word2Vec alone. The difference is that Word2Vec works on a single word within a document, and Doc2Vec works on the whole set of words within a single document. The Word2Vec and Doc2Vec algorithms are much more recent than Tf-Idf. They were invented in 2013 by Mikolov and team at Google. And naturally, being invented at Google, they were designed to handle Google-sized corpora. So let's assume that for every document in our corpus, we've already done the necessary prerequisites. We've done the various term extraction algorithms, and we have produced a preliminary bag of words for each document. Let's think now about just a single document within our corpus, and let's say that it has a total of Z terms in it. These are nouns and noun phrases most often. As part of producing this bag of words, we'll have the term frequency for each term within that document. Suppose that we're going to use the Tf-Idf algorithm next. That means that we're going to compute the IDF, or inverse document frequency, for every term in the corpus. We won't worry about the mathematics of the IDF right now. Let's just think of it as a mathematical function that's computed individually for each term within our corpus. By multiplying the Tf for each term by its appropriate IDF, we get the Tf-Idf. Then what we do is we take that set of Tf-Idf values and identify a cutoff point. Those values that are above it we keep, and those below we simply eliminate. This gives us a resulting reduced dimensionality vector. The important thing for us to keep in mind about Tf-Idf is that it's a one-to-one mapping. A single term in the initial vector gives us a single term in the resulting Tf-Idf vector. By way of comparison, let's look at the Doc2Vec method. As I mentioned earlier, it was developed by Mikolov and colleagues at Google, and it was designed to deal with very, very, very large corpora. Because the corpora used in a Word2Vec application are typically so very large, we have a big challenge. Our initial vector of terms is also very, very large, and we're trying to do dimensionality reduction. We're trying to bring this very, very large initial vector down to a reasonable size. To do this, The Doc2Vec algorithm thinks about the words that are near any given word that we're considering. It does a sort of neighborhood process. As a result of this approach, of thinking of the neighborhood of words around any given word, we wind up with a many-to-many term mapping. That means that each term in the input vector maps to multiple terms in the output vector, and also every term in the output vector can be mapped to by multiple terms from the input. In this case, our cutoff deals with the total number of terms that we want to have in a resulting reduced dimensionality vector, whereas previously with Tf-Idf, we were thinking about a numerical value for the cutoff that dealt with the smallest Tf-Idf value that we would include. So let's do a summary comparison. Tf-Idf is a one-to-one mapping, whereas Doc2Vec is many-to-many. When we think about the probabilistic aspects, we see that Tf-Idf is a simple probability, just the probability of a given term occurring, whereas Word2Vec is a covarying probability. We look at one variable occurring in the context of another. So let's see how these factors impact the practicalities. One of the most important considerations is your corpus size. If you're dealing with a megacorpus, Google scale, then probably a Doc2Vec is needed. But if you're dealing with a smaller corpus, and this is true for lots of practical and industry-specific applications, then maybe just a simple Tf-Idf would work well. Highly related to corpus size, and really more appropriate for thinking about what kind of algorithm to use, is how specific or focused your corpus is. One way to look at this is to ask yourself if there is a common or core vocabulary that is typically used throughout your corpus. It's not to say that you have to be restrictive. You're not forcing a controlled vocabulary, but if the same terms are frequently used enough, then probably a Tf-Idf will work well for you. In this case, using Tf-Idf makes a lot of sense. That's because you don't need to take any of your commonly used terms and express them as a vector combination of other terms. Every term is pretty much useful and distinctive and relevant on its own. So the third and final consideration is how much you, in your role as knowledge manager, have a deep and personal understanding of the corpus content. Do you know enough so that you can personally identify good equivalence terms? That's not just synonyms, but terms that function well enough that they can substitute for each other. This will let you set up classes of equivalence terms, and that will make your Tf-Idf much more effective. Also, you'll want to eliminate stop words, terms such as would, or things like action verbs such as accept or provide that are too general to be useful, but they've crept in nevertheless. Let's do a brief recap. With a very large corpus, one that spans many topics, and for which you don't have a great deal of intimate personal knowledge and it's difficult to model, probably a Doc2Vec will work. But if you have a smaller corpus, it's very focused, then Tf-Idf might be your preferred algorithm. Let's keep in mind that our current discussion is just on text vectorization. We haven't yet begun addressing the next stage, which is the things that you can do after you've got an appropriately vectorized representation for each of your documents. Hello again, thank you for joining me. I'm so glad that we could look together at these two comparable algorithms in natural language processing today. Now this vid is one in a series of vids on the same topic, NLP algorithms. And so following this vid, after we've had separate vids to discuss separately Tf-Idf and also the Word2Vec, Doc2Vec algorithms, we're going to take in some clustering topic mapping algorithms. For example, k-means and the well-known LDA or latent dirichlet allocation. We're also going to take a look a little later in the series about the role of ontologies, a rarely discussed component of NLP, but one that becomes more and more important. Join me.